Alright, here we go, 13-1. Representing sample spaces. So, first off, what is a sample space? Sample space is a set of all possible outcomes. We can show this as a list, a table, or a tree diagram. Alright, so now we're going to have a couple more definitions here, and then we'll do some examples. So let's do some definitions. On this side, and then we'll do examples on this side. And the example is going to have to do with a coin toss. So, a definition. So an experiment is a situation involving chance that leads to results called outcomes. So in a coin toss, your experiment would be the tossing of the coin. My experiment is flipping the coin up and tossing the coin. That's the experiment. All right, an outcome is the result of a single performance, or trial of an experiment. So, the possible outcomes are heads and tails. When you flip a coin, you get heads or you get tails. Alright, now the next definition is an event, and this is the last one, and we'll start doing some examples. An event is one or more outcomes of an experiment. So the example would be the coin landing on tails. All right. Now, let's look at some sample spaces. Let's do some examples here. Sample space. Let's look at the list first. So we're going to write out a coin toss that happens 2 times. So toss a coin 2 times. All right. We toss a coin 2 times. So the first time we toss the coin, let's say we get heads the first time. And then let's toss it again, and let's say we get heads again. All right? So, so that's one possible outcome of tossing the coin 2 times. Another possible outcome is the first time we toss, we get heads. The second time we toss, we get tails, right? Those are 2 possible outcomes when we toss the coin 2 times. This is when we get heads the first time, and then we get heads and then tails the second time. Now, what if we do tails the first time, and then tails the second toss, and then we get tails the first toss, and then heads the second toss? So these are all of the different possible outcomes of tossing the coin 2 times. And this is the way we do it with a list. Let's do it with a table. So the way we set up the table is we have outcomes. And we have, so this will be the first toss here. We can have heads, or we can have tails for the first toss. And then we can also, for the second toss, have heads or tails. So this is the second toss. All right, let's pull that down and over a little bit. There you go. So here are the outcomes. First toss, heads or tails. Second toss, heads or tails. And so we just write down what we get when these 2 parts meet. So heads and heads, tails, heads, heads, tails, and tails, tails. So we just look in our column and our row, and we just write what our results are. Notice these are the same results as the results in the list. Those are all the same possible outcomes when we toss a coin 2 times. Now let's look at the tree version, right? So we have list, table, and tree. So let's look at what the tree diagram looks like. The tree diagram, now you can turn it whichever way you want. It can go from the top down or left to right. So it depends on what you're doing. So we're going to start with the top down so it looks like a tree. Sometimes it's easier, we'll see later on, to go left to right, and it'll look like a tree on its side. But we're going to start with outcomes. We toss the coin, and the coin can be heads or the coin can be tails. So that's the first event. Now the second event, so we'll write first right here. And then we put the second here. For this flip, I'm going to flip it again or toss again, and I can get heads or I can get tails. For this second event, I can get heads or I can get tails. So I've tossed the coin once, I got heads or tails, then I toss the coin again, I toss the coin here, and so these are my possible outcomes. And so then I write down at the bottom my sample space. So I just follow my tree here, I follow my limbs, heads, heads, and then I can get heads, tails, tails, heads, tails, tails. So notice my sample spaces all end up being the same. It's just which method do we want to use, which one do we like the best. So let's do some examples. Try to help out with this. So this first example, we're going to toss a coin. Then a number cube rolled. All right, so we're going to do the list, we're going to do the table, and we're going to do the tree. So for the list, we're going to talk about, okay, I roll a coin, toss a coin, and I can get heads or tails. All right, so I can get heads, and I can get tails. And then a number cube is rolled. So the number cube, it's a six-sided die. Whenever the book says anything about a number cube, that's what it means, six-sided die. And so I can toss and get heads for my coin, and then I can get 1 on my number cube, heads 2 on the number cube, heads 3, heads 4, heads 5, heads 6 on the number cube. Or I could get tails, and I can roll the number cube then and get 1, tails 2, tails 3, tails 4, tails 5, tails 6. Those are all of my possible outcomes that I can get when first tossing a coin, then rolling a die. So let's look at what this would be on a table. So I got my outcomes. And I'm going to do heads and tails first. So here's my first event. My second is my number cube, so I can get 1, 2, 3, 4, 5, or 6. So I get heads 1, heads 2, heads 3, heads 4, heads 5, heads 6. And then I look down here, if I were to toss and get tails, tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. So that's my table. Now we're going to do the tree diagram. This time I'm going to do the tree on its side. Outcomes. I can get heads or I can get tails. And so that's my first event. And my second is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So my sample space is heads 1, heads 2, heads 3, heads 4. I'm going to list, just do that same thing with the tails. Heads 1, heads 2, heads 3, heads 4, heads 5, heads 6, tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. So I'm just listing the sample space, I'm just listing all of the possible outcomes. And we've shown it as a list, we've shown it as a table, and we've shown it on a tree diagram. So these are two-step sample space experiments. Now let's do a multi-stage, three stages here. So this is multi-stage. So here's our example. We want to write the sample space for this example. And this is going to be a coin toss. Then another coin toss. Then a cube, a number cube rolled. Okay, so for this one, we're just going to do the tree diagram. So we're going to do it on its side again, outcomes. So the first is going to be a coin toss, so that could be heads or tails. Then the next one is going to be another coin toss, so it's going to be heads or tails again. Should have spread this out a little bit farther. Then a cube rolled, so I go heads, heads, and then 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Tails. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So now I need to list my sample space. Here we go. Sample space. I'm going to have heads, heads, 1, 2, 3, 4, 5, 6. So it goes heads, heads, 1, heads, heads, 2, heads, heads, 3, dot, 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 all the way to heads, all the way to tails, tails, 6. On the homework, I'm going to have you need to list all of these out. But for the sake of doing notes here, I'm not going to write all of these. But, so you would say heads, heads 1, all the way to 6, heads, tails, 1, 2, 3, 4, 5, 6, tails, heads, 1, 2, 3, 4, 5, 6, tails, tails, 1, 2, 3, 4, 5, 6. So that's how this goes. On your homework, you need to list all of those. So this will be a big section of all of those, this whole sample space, all of those possible outcomes. All right, you try. You're gonna make a sandwich. And your sandwich, your size, is going to be a kid size or regular or large. And your cheese on your sandwich is going to be cheese or no cheese. Those are your options. You can have tomato or no tomato, T or NT, and you can have pickles or no pickles. So these are all of the choices that you can make to for your sandwich. And so let's, oh, this is a you try. So you're going to make a tree. You're going to start with your size. So that would be the first one. The cheese and no cheese, second. Tomato, no tomato, third. And then you have a fourth one, pickle, no pickle. So go ahead and make a tree diagram and then list all the possibilities. Pause now, go. All right, let's see. Hopefully you did all this work. I'm going to do it fairly quickly, hopefully. So I've got my outcomes. I'm making my tree here. I'm making it nice and large so there's room for all of this stuff. So I've got my first event, kids, regular, large. And then cheese. Cheese, no cheese. Cheese, no cheese. Cheese, no cheese. All right, my next event, so I've done that one, tomato, tomato, no tomato, tomato, no tomato, tomato, no tomato. For each one of these, I need to write tomato and no tomato. And last one is pickles. Pickles, no pickles. Pickles, no pickles. Getting squeezy here. Pickles, no pickles on every single one of these. These are all the possible outcomes of this sandwich. All right, pickles, no pickles. All right, now I need to go down each of these limbs here and list my possibilities. So I've got kids, cheese, tomato, pickles. There we go, that's that one. Kids, cheese, tomatoes, no pickles. Kids, cheese, tomatoes, no pickles. All right, so I've done those two. And that one. Kids, cheese, no tomatoes, pickles. Kids, cheese, no tomatoes, pickles. Kids, cheese, no tomatoes, no pickles. Kids, so now I've done kids, cheese. Kids, no cheese. Kids, no cheese. Tomatoes, pickles. Kids, no cheese. Tomatoes, no pickles. No tomatoes. Oh wait, tomatoes, no pickles. Sorry. It's very helpful to cross off what you've done. Kids, no cheese. Oops, let's just say no cheese. Kids, no cheese. No tomatoes. Pickles. Kids, no cheese, no tomatoes, no pickles. Now I've done those. So I've done all of the kids. Now I do the regular. So the regular is going to look exactly like this, but with R in front instead of K. The large is going to look exactly like this, except for L in front instead of R or K. So dot 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 dot. L, no cheese, no tomatoes, no pickles. But you should be writing all of that in there, but I'm not going to do that for the sake of what we're trying to accomplish here on this video. So here's what the tree looks like. So this, you should have a list that is this plus the R and this with the L, so that you have 3 times this many sample space, 3 times the size of the sample space. Okay, now let's do one more part of this lesson and we'll be done with 13-1. And that is, if you're trying to find the total number that you might have in a sample space, the total possible options. And so this is called the fundamental counting principle. And this is, we use this to find the number of possible outcomes. So all we do is we multiply the number of possible outcomes from each event or stage. Multiply the number of possible outcomes from each event or stage. Okay, so let's see how this works. So we're just trying to find, we're not writing out the whole sample space. We're just figuring out how many possible outcomes there are. So here's an example. We're just going to do 2 examples, and then we'll be done with 13-1. So if I was going to order a class ring, so I want to order a class ring, and there are a whole bunch of different options for this class ring that I can choose from in order to make my own class ring the way I want it to be. So here are the number of choices. So here are the options, and here are the number of choices. So for a class ring, you might get to choose which kind of metal you want. So there might be gold, platinum, whatever. So there are 10 choices here for the type of metal you can choose. Now there are different finishes for this metal. So maybe there's brushed and polished or whatever, 2 different kind of finishes. Stone colors. So the type of stone that you're going to get in there. You can have 12 different stone colors. Stone cuts. You can decide which type of cut you'd like, and there are 5 different stone cuts that you can choose from. And then you can have different logos. And there are 2 sides. So on side 1, you can have 20 different logos on side 1, and side 2 you can also have 20 different logos. And the last choice you get to make are the band styles. And there are 2 different band styles that you can choose from. So if you're going to order a class ring, you're going to see something kind of like this where you get to choose all of these different options to make your ring the way you want it. And if we were going to list a sample space of all of these different stages, it would be huge. And the way I know it would be huge is if I multiply 10 times 2 times 12 times 5 times 20 times 20 times 2, that's how many possible outcomes there are in this problem here. So if I multiply all those together, click, click, click on my calculator, I could just do this in my head. All of those multiplied together, 960,000 possible outcomes. So all you do is multiply 10 times 2 times 12 times 5 times 20 times 20 times 2. And that's what you end up getting here when you multiply those together. Easy enough. Let's do one more. You guys are going to try this one. So if you're going to go to the shoe store, you're going to buy some shoes. You've got the number of choices here on this side and the types of shoes. So you can choose different sizes between 5 and 11, and there are 7 different sizes that you can choose from there. There are 4 different colors of shoes that you can choose from. And then you can use leather or suede. So that's 2 different choices. And then your last choice that you can make here with these shoes is the width. So you can choose your width, and there are 3 different widths that you can choose from. So tell me the total number of possible outcomes in this scenario if you go to the shoe store and you have these different choices that you can make. So pause it,